Now, to understand the complexity of the private inheritance when the base class members are private, let's look at the example. Now, if you look at the code on the right hand side, you will find that there is a class A which is a base class. Now, in this base class, we have a variable which is A, which is declared as a private variable. We have inheritance wherein class B is inheriting class A and the type of inheritance is private. Now, if you look at this scenario, we have an issue. The issue is that this A, which is the private member of the base class, when it gets inherited, it gets a double layer of security, which means that first of all, you cannot access this directly through an object. That's completely not allowed. Second, you can't even access this using a public member function of the derived class. Now, if you look at the derived class, we have getVal, which is the public member function. So how you can access the private data of the base class? Now, what we need to do is we need to access the private data of the base class using a public member function of the base class. So if you look at this, A is equal to 9. So we are accessing the private member of the base class through a public member function. Now, this public member function has to be invoked by a public member function of the derived class. So there is a two-step process. So getVal, which is a public member of the derived class, invokes show, which is the public member of the base class, and this show basically accesses the private data. Now, the disadvantage of this method or private inheritance is that you need to write a lot of code in order to access the private data of the base class. Now, this is exactly the reason why there is the third access specifier, which we haven't discussed in this details, and that is the protected keyword. Now, if you recall the previous classes where I have told you that private and protected are exactly the same for an independent class. However, we are going to look at how the protected keyword is going to be useful in inheritance. Now, when you have a member which is declared as protected, for that class, it is private. However, when any derived class is inheriting the properties of the base class, then the two-step access that you see here will be reduced in case your member is declared as protected. So let's look at an example and see how exactly that is done. Now, I'll just look at it through another problem. Here is a small program which shows that A is a protected member of the base class. Now, if you look at this, it's very simple. We don't need a public member function of the base class to access this A. How we can access is very simple. We can access it by a public member function of the derived class. So getVal, which is a public member function of the derived class, is able to access the protected member of the base class directly. Now, this helps us write the same code with the same level of security, but by using less number of lines of code. Now, what is the advantage of this? The advantage of this is A is private to class A. The member variable A is private to class A. However, it is easily being accessed by the derived class objects through a public member function of it in case of inheritance. Now, the question is, when should you make a class member protected? Now, this question, in order to answer this question, we need to understand the design. If you think as a solution analyst or a technical lead, if you think while designing the class, while designing the architecture of inheritance, if you think that a particular class is a prospective class for becoming a base class, then all the members of that class, in fact, the member data of that class, should be made as protected. And that is how the protected keyword is useful. So you have seen now that we have used three keywords, which are also the access specifiers, which is private, public, and protected. And now you should know the difference between the three. Now this is a very important question. Public and private is simple because we use it in different contexts. However, protected is used only in case of inheritance. Now this is a question which is asked very frequently in your placement interviews, so you must not forget it. Now these three concepts which we discussed, the private inheritance, the public inheritance, and also the use of protected in inheritance, are the most crucial concepts in inheritance when you talk about C++. Inheritance can be of different types, and we have discussed this in the class, and I'm just going to skip through this because this is supposed to be a revision session. And the reason I covered the public and private inheritance is because they are important. So in case you've forgotten, which I definitely think you must have in this long break, just recap, remember, and come back. So I'm just skipping these slides of inheritance, different types. We've done the single inheritance, multiple, hierarchical, and we've also discussed what is a hybrid inheritance and the multipath inheritance. Also, what is the problem of multipath inheritance and why multiple inheritance is not allowed in Java. So all that has been discussed. We've also discussed the virtual base class. There is a problem here in this slide wherein the properties of A are being derived by B and C, and D is again a derived class which is deriving all the attributes in B and C. So D basically gets a duplicate copy of A through B and C. So how do we solve that problem? By making the base classes virtual. So we have discussed all of this, so I'm just skipping through this. Now this is also very simple, and we have also discussed it many times, that when you have inheritance, there is a sequence in which your constructors are actually fired. So the rule is the base class is created first, the base class object is created first, and then the derived class object is created, and that's the sequence in which the constructor will be fired. So we have done all of this, so I would request you to kindly go through this. I've also given you the slides, so there should not be any problem. And in case you have a problem, please feel free to ask me again. You can just call me, send me a message on WhatsApp, and I can explain it to you, provided you go through it yourself once. So all these things we've also discussed about different combinations of constructors which are parameterized and which are non-parameterized and default, and how they would be called. So again, if you are having a problem in this, please ask me. And finally, we also discussed what happens if you don't have a default constructor in your base class and there is only one constructor which is a parameterized constructor. However, when you create an object of your derived class, it tries to look for the base class default constructor. So in case there is no default constructor present, then what happens? So in this case, we must explicitly call the parameterized constructor of the base class. And how do you do that? It's specified here very clearly. This is the place where you call the parameterized constructor of the base class explicitly. So we've done all of this, but still you have a problem, please get back to me. Constructors in multiple inheritance, also it has been covered in the class. We've done it well many number of times. And also, if you want to change the sequence of the constructor being called, you can use the virtual keyword, and it's very simple, and we've done it. We've done a lot of exercises on this. Again, constructor execution in multi-level inheritance, you go right from the base class on the top, and then you go to the next base class and then the derived class. So that's how it works out. We have discussed delegation. We have discussed delegation and what exactly does it mean. So this is another type of relationship between two objects. So in this, we have the whole object and the part object, and the whole object basically delegates the part object with whatever work it has to get it done. So it's the concept of delegation is simple. You have a boss and you have members who are working for the boss. The boss is the whole object and the members are a part of him. So if any work comes to the boss, he delegates it to the members. So this is basically the concept of delegation. So how exactly does delegation work, and how do you write a code for delegation? So basically you have class A and you have another class B, and inside the class B you declare class A, like you create an object of class A. So what happens in this case, the only property that you must remember here, also I forgot to tell you that class B is also called as a container class because it contains an instance of the class A. There is no inheritance here. That means delegation is completely a different kind of relationship, nothing to do with inheritance. Alright, now the main property of delegation is, look at this example here. Let me just get out my pen, and here we go. So here we have class A and we have class B. Now inside class B I'm creating an object of class A, so which is the whole class and which is the part class. So class A is the part class and class B is the whole class because it also consists of the object of A, right? So when I create the object of the whole class, that is BB here, which you see, this is basically I'm creating an object of the whole class. Now what happens here is, before the constructor, that is this one, before the constructor is invoked, it first looks at the class and finds that there is another object which it needs to create. So what it does is, before it creates or invokes the constructor for B, it goes and invokes the constructor for A, and then it comes back and invokes the constructor for B. So that is a property. So it's simple. So if you have a whole object and you, for example, you have a door, and the door is made up of small different parts. For example, the handle, the hinge, and the glass, and the wooden bracket and all that. So before you construct the door, you must bring all the part objects. So you must manufacture the part objects, and those part objects, when you put together, you get a whole object. So that's the same concept here. So before you manufacture or create the object for class B, you must manufacture the different parts, which is all the objects of class A. And that is basically the concept of delegation. We are going to discuss delegation and this whole part relationship, which is also a hazard relationship, when you study object-oriented analysis and design. However, for now, this much is more than enough. And we've also looked at how you can inherit from a qualifier class, which basically has a nested class, and we have seen it's very simple. We've also looked at what a common constructor is and how you can use it, and how you can overload member functions from both base and derived class. So if you look at this simple example diagram which we have discussed in the class, we have two classes here, where class B is inheriting from class A. You have show method, which has the same name. So you have two methods with the same name, one in the base class and one in the derived class. So when you invoke using an object of the base class, you get the base class show. When you invoke the show using the derived class, you get the derived class show. And if you want to invoke the object, if the object B wants to invoke the base class show method, then we must use the scope resolution operator, and you are very familiar with how we need to do this. So we have done this many number of times, and this is how you need to do it. So for this chapter, more or less, this is it. And I have not given you any assignments yet, but I will be giving you some programs based on it probably tomorrow or day after. Now these programs are going to be your lab programs. So please write those programs and see how inheritance works. And you also need to put them into your assignment. When the college reopens, you can submit it as an assignment, and when we have the lab test, these programs are going to be a part of it. So it's important for you to understand this concept of inheritance. It's comparatively easier than the other chapters. We've just finished a chapter on operator overloading, which was pretty complex compared to this one. However, inheritance is important because